This video looks at internet communications. So, the internet. We have heard about the internet in the previous two videos. What is the internet? It's a massive network of networks, a ginormous collection of connected computers. So, these connections, they span the globe. There are thousands and thousands and thousands of different routes from one computer to the next, all across the world. Cables can go across the land, but they can also go under the ocean as well. And there are huge amounts of cables which lie along the ocean floor, connecting continents to one another. So, how does data go from one computer to the next across the internet? Well, data will be split up into tiny little data packets. So packets get sent by different routes according to availability. It's not necessarily the shortest route, but it certainly is those that are available. So when you send a file online, the parts of the file might travel one way around the world and the other parts might go the opposite direction. Provided there are available channels for those data packets to go, then that's the direction of travel that they will each take. Packets are then reassembled at the receiving end, and a typical packet structure, well, it's certainly not going to look like a truck, but you can think of it as a vehicle which carries data. But in addition to that, this data packet will have a destination address, we'll have a return address, we'll have a sequence number, and we'll also have an error check. So let's have a look at these in a bit more detail. So obviously a data packet carries data. A file, perhaps a Word document, is going to be split up into millions of data packets, each containing some data which would be the building block of that document. But the header, contains really important information to ensure that the data packet goes the right way, or goes to the correct computer, the correct destination. And also, if there's a problem as it's traveling across the internet, then the packet header will allow for a new data packet to be sent out. So it's got a sequence number. Remember, data split up into different packets, so the sequence number allows the file to be rebuilt when all those packets are then collected by the destination computer. It has a return address, and the reason for that is so that once the data has arrived at the destination computer, the original, or the computer that sent that data, can be notified that the data has been correctly arrived, it's been received okay. Now, if the data packet arrives corrupted, which can happen, then obviously because we've got a return address, we know that we can request that data packet again, so that we can obviously get all the data needed to reform the original file. And obviously it's got a destination address. It needs one of those so that the file, or the data packet, can be sent, can be routed to the correct location. Now it's also got an error check. Okay, it's a really important part of a data packet. So it's got something called a checksum number. Okay, now a checksum is made up of a calculation that's carried out on the data packet and an answer, a correct answer. So if this calculation before the data packet is sent is carried out on the zeros and ones that is the data packet, and it comes up with a particular answer, it means that once this data packet is then actually sent over to the destination computer, it can check that the data is still intact, because the destination computer will be able to carry out that same calculation on the data inside the data packet, and if it also results in the same answer, the correct answer, then we know that the data hasn't been corrupted on its journey. If, however, on its journey some of those zeros and ones have altered slightly, when the calculation is carried out at the destination computer, it will produce a wrong calculation answer, and therefore the destination computer knows that it needs to request that data packet again. So a checksum number is included in a data packet, and it's a crucial part to make sure that the data that's received is the data that was sent. So how is data sent across the internet? Well, as we said before, it's split up into lots of data packets. It's then sent out onto the internet. And these data packets are routed across the internet according to available routes. They won't all go the same along the same routes. They'll be routed to wherever's available. They'll then be received at the destination computer, and because they've got sequence numbers, they'll be able to be pieced back together, and we'll be able to see that on the that file will be received at the destination computer and can then be worked on. So, IP addressing, MAC addressing, and protocols. So data obviously is sent around the internet in data packets, and because the internet is full of billions and billions of different devices, all of these devices have to be able to speak the same language. They all need to follow the same rules so that they can all function together. So, if these data packets are produced and sent in the same standard way, then all of these devices are obviously going to be able to communicate with each other effectively. So because of this, the internet is full of rules which we call protocols. Okay, so it's just, as it says here, a fancy name for rules, full of protocols. So if you think about the fact that there are so many different devices on a network, loads of different nodes, these devices, they're all going to be manufactured by a range of manufacturers. For these devices to all work together, they all have to be manufactured according to these protocols. Otherwise, certain devices just won't function along with the others. So we'll have a look at some major protocols which allow the internet to work. And it says here they sound scary, but they're not. It's just a lot of them. Just go with it. Okay, MAC addresses. So, us humans, we've got postal addresses. So every house has its own address. That's so that we know if we want to have a delivery, then the delivery driver knows where to send it. Similar to that, every network card in the world has got a MAC address, a media access control address. And the MAC address is hard-coded into every network device. It cannot change. Okay, it's hard-coded. It's not dynamic. It will not change. And it's a 12-digit hexadecimal number. And it's there so that data that is being sent over the network can be sent to the correct network card. It's known as a physical address. Now, an IP address, you could get confused with IP addresses and MAC addresses because they're both addresses for devices on a network. So, just like a network card has a MAC address, every computer that goes on the internet will be given an IP address. They're usually a 32-bit number written as 4 decimal numbers. And they're required for the same reasons. That data that's been sent over a network can be sent to the correct place. The main difference is that an IP address is dynamic. Okay, it's not hard coded into the computer. It is dynamic. It can change. And the reason for this is so that on a network you could have similar types of hardware that can be all grouped together by being given similar IP addresses. So all computers, for example, on a particular network could be given an IP address starting 190. Printers could be given an IP address starting 200, and so on. So what it means is that different types of devices can be more easily managed on a network. So it might be your ISP gives you an IP address which starts off similar to other similar devices or that it manages. Or your network manager in your school might choose to assign all computers with IP addresses that start in a similar way, all printers that start in a similar way, so that they can better manage the network. So MAC addresses are hard-coded, IP addresses are dynamic. The TCP IP protocol. So this is really, really important when it comes to how data is sent around a network or around the internet. And it's actually 2 protocols. You've got the transmission control protocol, and this governs how data packets are split up before being sent across the internet. So it ensures that all data is split up in the same way. So data packets are created in the same way. It ensures that these data packets are put back together when they're at the destination device. It ensures that data received is the same that is sent. So if you remember, data packets have an error check. that transmission control protocols ensures that data packets do have those things. And the IP, the Internet Protocol. This is a rule which makes sure that data packets are directed towards their destination in the most appropriate way. As I've said before, it might not be the shortest way, but has to be the most appropriate way. So together, these protocols govern how data is sent across the internet. Now, this is called packet switching. Any data that is directed towards its destination in the most appropriate way is known as packet switching. So this is how it works. A file is split up into data packets, and they're sent out onto the internet. Routers follow the IP rules, and they direct data packets towards their destination. So because there's different traffic at different parts of the internet, packet switching may occur. So data packets might take different routes and be directed to other routers before being arriving at the destination computer. And obviously if the packets are in the wrong order, the packet numbers can help reorder them and get the destination computer to piece back those data packets to create the original file. So packet switching ensures that data gets to its destination as fast as possible. This may not be the shortest distance, however. So that's packet switching, where you have a file that is split up into data packets and sent across available pathways. And it's really, really efficient. But there is another method called circuit switching. It's an alternative to packet switching. And it has some benefits, but it also has a few drawbacks. So let's have a look at circuit switching. So as we've already heard, packet switching is a good way to enable devices to communicate on lines or on network cables that are shared by vast numbers of other devices. So if you think about the internet, you've got millions of different users, and they'll be sharing those communication channels. So the way in which, the reason why they can share it is because the data files are split up into tiny packets, and they can be channeled alongside other data packets along those channels to get to the destination computers. You can think of it like grains of sand. Okay, if you think about an hourglass, if you had a block of sand that was all just one big blob, you could think of that as a file. It's not going to be able to get through the channel. It's not going to be able to get through the hourglass. If you were to split that up into lots of different grains of sand, they can all share that same channel to get to the bottom of the hourglass. And it's a similar idea in terms of why data is split up into packets, so they can share those same those communication lines. Now, circuit switching is another way to get two devices to communicate. It's actually inferior in many ways. Circuit switching is where you actually have a dedicated communication channel between devices that want to communicate with each other. So this is the case when people phone one another. Okay, a switchboard will route calls from one person to another. It means that there's no delay in receiving the data, but it massively wastes the bandwidth. Because no one else is sharing that communication channel, lots of that bandwidth is just going to be unused. Furthermore, it can be used by two devices. It can only be used by two devices when we send and receive data at the same rate. So packet switching is much more efficient. Circuit switching is another way that data can be sent, but it is a less efficient way. Okay, World Wide Web, so the website protocols. HTTP, the Hypertext Transfer Protocol. So this rule is a way to govern how websites and browsers communicate. So it means that if all websites are following the same rule, the same protocol, it means that it doesn't matter what browser you're on, all browsers, all the standard browsers can access those websites, can access those web servers in the same way. Now HTTPS is exactly the same really as the above. The only difference is that it ensures that any data that is sent from the client to the web server is secure, it's encrypted. So it's scrambled, so that if the data was intercepted, it wouldn't be readable. So if you're ever giving your personal information, bank details away on a website, make sure you got that padlock, make sure it's HTTPS, otherwise the data that's sent may not be encrypted. File transfer protocols. So file transfer governs uploading, downloading, reading and writing. So FTP. So if you've got documents on a file server, the way that you actually access and download them, or the way that you upload them, is governed by the file transfer protocol. Okay, so it just ensures that all of the clients on a network access files from the file server in the same way. So there's some email protocols as well. So the post office protocol, known as POP. So this is a protocol which governs how emails are accessed from the email server. So an email client, which might be Outlook, will use this protocol to access emails from the server where those emails are stored. Now, IMAP, Internet Message Access Protocol, really similar to POP. So it still governs how emails are accessed from the server by the client. But the difference here is that once an email has been accessed, it will remain on the server. So it might be downloaded by the client and stored on their PC or on their phone, but the actual email will remain on the server. And the reason for that is so that nowadays, we access our emails on our phone. We might then go onto a PC and access our emails. We've got lots of different devices that access emails. We don't want it to be that our phone downloads an email as soon as it comes into the server, and then we can't then read that email from the server when we go on our desktop PC. So it means that the email will stay on the server. It doesn't matter what devices you've got. You can all synchronize your emails across all of those devices. And then you've got the SMTP, the Simple Mail Transfer Protocol. So this is the protocol which governs how data is sent between mail servers. So not so much between a server and a client, but between mail servers. So by conforming to those same protocols, those same standards, emails can be sent to and from all mail servers across the internet. So the internet. If you think about all of these protocols, they all enable the internet to function correctly. And they can actually be divided into different layers of the internet. Now, each layer of the internet, each layer of a network, has similar functions, and each layer provides a base for the next layer above it. So it says here, each layer does all the hard work for the layer above it. So let's have a look at these layers. So you've got the application layer at the top. Underneath that, you've got the transport layer, then you've got the network layer, and right at the bottom, you've got the data link layer, or the physical layer. Now let's think about how it is that each layer does all the hard work for the layer above it. So let's start off with the top layer. So this is basically the applications of the internet. So websites, files that you can download, email systems. These are all the applications of the internet. Now you can't have the World Wide Web, you can't have the email systems unless you've got an ability to actually transport data between different devices. So the layer underneath it is the transport layer, and this is the layer which provides transport between devices by splitting up files into data packets and checking that they've been sent and received correctly. Now you can't actually transport data, you can't split data into data packets and transport them unless you've got routes through which those data packets can actually be sent. So underneath layer 3, you've got the network layer. So this provides the routing of data across the network by making use of addresses. So if you've got your data and you want to sort of transport it from one place to the other, you can't do that unless you've got an ability to actually route data from one address to another. So that's where the IP address, IP protocol comes in. And you can't actually have data being sent from one address to the other unless it's got a physical channel through which it can be sent. So layer 1 is the data link layer. It's governed by the Ethernet protocols, and it provides that physical transport of data through electrical signals. So you've got your 4 layers here, and each layer cannot function without the one beneath it. So it says here, for example, if you are accessing a website, it requires data to be split into packets and sent across the internet, and that's layer 3 and 2, which in turn requires the physical transport of data via cables, which is layer 1. So all of those layers work together, but the top layers cannot work unless the layers beneath it are present. So you've got physical and you've got logical protocols. We've looked at loads of protocols just then, but they can be divided into physical and logical protocols. So the protocols that govern the internet can be grouped into these different categories. Physical protocols are rules that govern the physical mediums through which data is traveling. So it might be the rules that govern cables and wireless technology. And then you've got logical protocols, which are rules that govern how the data is sent. So in terms of maybe governing how data is split up into packets and routed from one place to the other. So a few examples of physical protocols could be wired or wireless protocols, serial or parallel data transmission, copper or fiber optic cabling, and so on. And logical protocols might be things like bit rate, error checking, packet size, ordering of packets, routing, compression and encryption, digital signatures. So you've got your physical protocols, you've got your logical protocols. And finally, handshaking. So when two devices communicate over the internet, they need to decide on certain protocols so that their communication can work efficiently and effectively. And the decision where two devices decide on those protocols, that's known as handshaking. So it's carried out by one device sending a list of protocols to use and the other device going, yep, okay, I'm fine with those protocols, let's carry on. And if a device fails to agree with the choice of protocols that one device has sent, then another set must be chosen, or they will not handshake and they will fail to communicate between one another.